So hopefully you can see the title slide.
We can, yes.
Lovely. Let's kick off then. So thank you everybody for joining. Good afternoon, good morning, or hello, wherever you may be. Thank you for joining me this evening for my session on creating a metadata-driven framework using Azure Data Factory and a few other Azure resources. I'm very pleased that you managed to tear yourself away from the Microsoft Build conference to join me. So that's a big honor that you'd rather listen to me than listen to them. So thank you again. As Michael has said, my name is Paul Andrew. I'm a principal consultant with Altius based in the UK. And there's a few links to my social media and things there at the bottom as well. As Michael has already said, the slides that I'm about to show you, they are already in my GitHub repository, the community events repo, and then there's some subfolders in there for the event, the location, and the date and time applicable. So there's already a PDF of these slides in there. I'll show this link for you at the end as well. Please help yourself. So let's kick off then with Azure Data Factory, definitely one of my favorite Azure resources. And to kind of take you on this story and build up to where we're heading with this metadata-driven framework, let's just start with Data Factory itself. And for those that are new to the service, let's just take a very quick look, very quickly, at what Data Factory actually is and what it means for us when we're working within Azure. So if we ask the question, what is Azure Data Factory? And we think of it in the context of some process, something that we want to happen. As data engineers, we want to get our data from A to B to C, using whatever tools and whatever is appropriate for the data that we're working with. In the context of this process that I've got at the bottom of the screen, we could say that Data Factory is the umbrella service. It is the orchestrator that will sit above that control flow process. It will monitor, it will manage, it will schedule that process that we want to happen. And it sits there, say, as the orchestrator is kind of the key word here for Azure Data Factory. Then to go a little deeper and actually think about the components that we have within our Data Factory, just to really sort of complete the question here of what Data Factory is. And again, within the context of this process that I've got going from A to B to C, we have 5 things that we need to create within our Azure Data Factory. Number 1 is this idea of a link service. The means that we give Data Factory to authenticate against something else. Could be on premises, it could be in Azure, and we create this link service, and if we were talking to a SQL database, for example, the link service would contain the host name, the database we're talking to, maybe the username and password, or we're talking to a key vault, whatever. I think last time I checked as well, Data Factory had just under 100 different link services now that it could interact with, with those credentials and connection information. So that's number 1. We need a link service for Data Factory to talk to something. Then number 2 is this idea of a data set. Now, this isn't necessarily the actual data that we want to work with, but this data set is something that we create within Data Factory as a component. It will authenticate using our link services, number 1. And again, if we take the example of an Azure SQL database, the data set will contain the information about the table that we want to perhaps work with. Maybe, its schema name, the table name, the data, the attributes that exist in there, their data types, all these things that data set will contain. So almost metadata that represents the data that we then want to work with and authenticated with our link services. So that's number 1, number 2. Next up, number 3 is this idea of an activity. So the activity within our Data Factory will contain information specific to the thing we want to do, and information specific to the service that we want to interact with. So if we take the example of a Databricks notebook, we would have an activity there that uses our link services again to authenticate. But then the activity for the notebook, we would specify the workspace that we're going to, the path that that notebook exists within the workspace, maybe some parameters that we want to pass to it, maybe some extra libraries that we want to pass to it. So that activity is that information specific to the service we're going to work with at that point. Then moving on to number 4 is this idea of a pipeline. And what you'll see from this image at the top of the screen is that I've wrapped this process in these 2 logical pipelines. And that very much is what these pipelines are within the context of our data factory. They are wrappers almost for those activities and those things that we want to do. We can have many activities within a pipeline. We can have pipelines calling other pipelines, as we'll see later on, but they sit there as a component of Data Factory. We could say this whole process that I've got with the orange arrows going from A to B to C is our data pipeline. Yes, fine, but also be aware when we're being careful with our terminology, a pipeline is also this logical wrapper that we have within our Data Factory. So that's number 4. Then finally, number 5, this idea of a trigger. So we would attach a trigger to our pipeline, and it's that trigger that will allow us to execute that pipeline. And these triggers can take a few different forms. We can do it manually. We can use this idea of tumbling windows. We can schedule things, which is very closely aligned to what we perhaps are used to if we've ever come across our SQL Server agent. So triggers can be scheduled in that way. We can have triggers that will detect events from our blob storage. So when a file is created, that trigger will kick off the pipeline. We can do a few things there. And as I say, those triggers, number 5, will attach to our pipelines, number 4. Our pipelines contain our activities, number 3. And then our activities and our data sets, 2 and 3, will authenticate with our link services, number 1. So that's very much a whistle-stop tour of Data Factory, what it is and the components that we use within it. So if we come back to that orchestrator, as we like to illustrate, and we can say that this orchestrator has its hymn sheet of JSON, if that's not too much of a labored metaphor. So that's our Data Factory. But then if we focus more on the JSON that goes into it, what we'll find is that for the first 4 of those components we have within our Data Factory, the JSON that we create can be dynamic. We can inject into this JSON with expressions and we can pass in parameters and variables and all these things, which means that we can then create a very powerful set of operations within our Data Factory because of how dynamic we can create these 4 components. The way we do that via the Data Factory developer UI is using an expression builder. As if we ever used SSIS, the expression builder we get in sys packages, we kind of have an equivalent thing here within our Data Factory environment. And within that expression builder, we get a lot of functions to support the things that we're doing in our expressions. And what you'll find is when you're moving around the Data Factory UI is you'll have a box where you want to put some detail to drive something. And what you'll probably see is that underneath that box, it'll say add dynamic content. If you click that link, that's when it'll bring out the expression builder, and that's when you can start injecting into the JSON that makes up those first 4 Data Factory components. So that's some foundations around Data Factory, just to, if you're not familiar, and just to give us a starting point. Then if we change gears though, and if you've ever been working with Data Factory, what I want to do is to better frame the context of where we're heading in this session, is say to you that we have a problem. And that problem could be, how do we structure our Data Factory pipelines? And you think, well, that's not really a problem, that's fine, but let's just explore that problem a little more. Again, I'm kind of setting the scene here. So what we could say is that within our data warehouse solution or a data platform solution, whatever we want to call it, we have a data lake. And because we're good developers, our data lake may be structured something like this, with separate containers or subfolders or however you want to layer it. But the ultimate goal here is the curation of that data. We want to get that data from left to right as data engineers. And as we go through those layers of our data lake, we're basically enriching our data sets and doing whatever we need to do to it to then get insights from it at the far end. So hopefully that's a fairly common pattern, a few assumptions and a bit of vagary there thrown in for good measure. So to support that chain of events, to support the curation of that data through our data lake, we would use probably Data Factory to orchestrate that. And let's say for the argument's sake and for setting the scene that we have 3 business processes that we want to take through here. And I'm going to very originally call them 1, 2, and 3. So then for each of the layers of our data lake, we say that between each layer, we have an activity within our data factory. So we've got 3 pipelines for our 3 business processes, and all I'm doing between the raw and the clean layers is a copy activity. Maybe then between my cleaned and transform layers, I'm going to use some Databricks notebooks. And then maybe from transform to served, I'm going to have some Azure functions, maybe to process a model or do something else, who knows. So 3 pipelines, 3 business processes, and what we could probably do is actually put all of those activities for the first business process in the first pipeline, all the second ones in the second pipeline, etc. So we could say that those pipelines are now aligned to the horizontal planes that they're going to be processed through our data lake. That's fine, that works. That's, it's a reasonable starting point. And, if there was nothing more that we needed here, this is okay. This is good enough. But we then, for whatever reason, end up with a problem. We end up with a dependency between our number 2 process and maybe its raw data, and our number 1 process, and then what we perhaps need to get from clean to transform. For whatever reason, we could have some late arriving facts, or who knows what the situation is, but we have that dependency there. And because of that dependency that crosses those horizontal planes of processing, it means that we can no longer separate those pipelines in the way that I've alluded to with the dotted arrow, the dotted lines. So that doesn't work. So say, okay, fine, that's not a problem. Instead of doing horizontal processing planes, I'm just going to say I'm going to have vertical processing planes. So maybe I have a pipeline that contains all of my copy activities, and then another vertical pipeline for all of my Databricks notebooks. Again, fine, this could work, but you can probably imagine where I'm going with this. I say, well, okay, but we then end up with another dependency. We now end up with a dependency between our number 1 processing and our number 3 within that same vertical plane. So that is then no longer going to work for us. We need to do something differently. It's okay, fine. We can deal with this. We scrap that idea of the horizontal and the vertical, and then what we do is we actually have pipelines at the most granular level. So maybe we have a one-to-one relationship between our Data Factory pipelines and then that one activity that they contain within them for whatever that process may be. So if we do that and we go really granular, and we have loads of these pipelines within our Data Factory, there's the obvious things around managing it and dealing with it, but we could then say that that supports these dependencies. We can, in theory, now connect all of these pipelines up, and we can have a series of success arrows between them, and that will deal with that dependency problem. And then what we could do if we wanted is we say, well, for all of those lowest level pipelines where we have that one-to-one, we're then going to wrap them all in this idea of this new parent pipeline or a grandparent pipeline, let's say. So that grandparent pipeline that I've put on the top of the screen here in green, that grandparent now contains all of the lowest level executions of all the activities we want, and we can chain them together within that grandparent, and that's fine. Now, maybe we go one step further here, and actually maybe we say, well, there isn't dependencies between all of these lowest level things. So what I'm going to do is, to try and make things a little easier, I'm going to consolidate some of those common processes. I say, okay, fine. So maybe we do that, and maybe we consolidate the copy activities for our processes 2 and 3. And let's say that we put those into a parent pipeline that contains these common things. And then where we have these interdependencies, we have the more granular child pipelines that deal with that. And you can see I've also consolidated the pipelines on the far right-hand side for the operations that we do or we use to go from transform to served. This could work. We have the obvious management overhead here again, but we could say, as a definition, our grandparent pipeline is what we use for all of our processing at the top level. We then have our parent pipelines to consolidate these common things that we want. And we say that our child pipelines are used for those lowest level dependencies. As a definition, as a kind of baseline, this could work. This could be okay. It's not ideal. There's a lot of lines here, and you could end up with a lot of spaghetti on your screen when you look at your grandparent, and maybe the management of going into those parents might become a bit confusing, and you might have to refactor them over time. So hopefully this alludes to an obvious problem, that this isn't ideal. It will work, but not ideal. The other thing that we're then going to encounter as well is that within our grandparents, there is a limitation of the Data Factory service. And that limitation is only going to allow you to have 40 activities per pipeline. So you can imagine, for a very large solution, maybe you've done a lot of refactoring into those parents, but then maybe you have a lot of dependencies as well. 40 is not a big number. You are easily going to hit that limit, or I have certainly easily hit that limit a few times now with those activities per pipeline. So we've got this potential hard limit on the Data Factory service, and we obviously have this management overhead and things here that isn't great when it comes to dealing with these dependency chains as well. So hopefully that's a really good sort of setting the scene here for the problem that we're now sort of leading to, and where we could find ourselves with a potential solution. So from that then, drum roll maybe, the obvious solution here is to then use metadata to drive our Data Factory pipelines, and making those Data Factory pipelines as dynamic as possible to deal with the thing that we want to do. So given the solution I'm leading you to, let's revisit that sort of business process dependency chain type problem, and let's go back to what I said about having pipelines for the most granular parts of that process that we want to do. Now, Data Factory as a service, it has none of its own storage and not really any of its own compute. So it can't deal with this on its own. It can't use its own metadata, unless we store it in JSON files or something like that. But even so, it's got to call out to some storage to get this metadata. So if we're calling out to another service anyway that we need to house this metadata, why not use an Azure SQL database? It would certainly be my service of choice, because I probably have a bias of starting life working with T-SQL. But what we can then do is, with this relational engine, choose as you've see fit, but for an Azure SQL DB, we can obviously within there create a couple of tables. The first one to deal with our stages of processing, and then a second one to deal with our pipelines. So you can see, the translation or the mapping here of what I've got as 1, 2, 3 and ABC in my top level. And at that granular level, what I'm going to now describe these as is the worker pipelines. The worker pipelines that are already there doing the thing that I want. So I can say I have dependencies between all of my worker pipelines that exist in stage 1. So all of those stages, all of those worker pipelines within that stage need to finish first before I can then move on to stage 2. Obvious, right? And using the power of T-SQL, I can write a very complicated select statement that joins my pipeline metadata to my stage metadata, and we can then create a table, maybe looking something like the one in blue, that has these stages aligned to the pipelines themselves. And we can clearly see those dependencies potentially there between the stages. So what we can then do is, once we're armed with that metadata, we can revisit our data factory. We can keep those worker pipelines intact, so they will still remain, but we can clear down everything that we had before, and we can now say that I'm going to have a series of parents that have those dependencies and they will adhere to that. So those parent pipelines will execute sequentially because of those dependencies that we have between them. And then within that processing stage, we can say that I've got a bunch of other pipelines that they don't have any dependencies. They can all execute in parallel. So we can kind of come back to that vertical versus horizontal processing, but now we can say that we have this vertical chain of events because of the dependencies that we need to have in place. But then within that chain, we can then scale out horizontally for any of those pipelines where there is no interdependencies. And what we can do for completeness is we can say that for those scaled out processes, we can then align those back to the worker pipelines that we already have within our data factory. So this is obviously high level theory. How do we then actually implement it? Well, to answer that question, we then run into another problem, unfortunately. And if we say that within our pipelines, when we hit these workers, we just need one pipeline to call another, which is fine. And you might be thinking, yeah, I know how to do that. I can use the execute pipeline activity within Data Factory to do this. But there is a problem. That magic add dynamic content button that I alluded to at the start, that does not currently exist for our execute pipeline activity. So although the execute pipeline activity can call a worker, we certainly can't do it dynamically. We certainly can't do it driven by some metadata. So there's a problem then. And if we come back to that theory of that framework and that metadata that's going to drive this, we then need to think about that individual execution between those pipelines and those workers. So in the top right-hand corner is this idea of the interaction between those pipelines that are going to call the workers, and what do we do about it? So there's a few different options here when it comes to actually making that interaction between what is the framework pipelines and those workers. How do we make that dynamic? One option is to use the web activity and the webhook activity. So we can actually hit the Azure Management API and we can pass in information about the worker pipeline that we want to interact with, and we can use these calls to that management API to actually do the work for us. We can also use these web activities to authenticate as well. And what I've put down there at the bottom is a link to a blog post from the Microsoft UK team, where they've basically done exactly that with orchestration in Data Factory. And what they've done is they've chained multiple data factories together and many pipelines, and they pass off these calls to the workers, as I'm going to describe them, using a web activity and using that management API. So that's one approach. That works. We can do that. That's fine. That's option one. Option two, as you may be aware, is that we could use a logic app. We could hit that logic app with a web activity, and then maybe within that logic app, we have actions that then call back to Data Factory to run the worker pipeline. That's fine. We could do that as well. That's another option. My preferred option, though, is actually to use Azure Functions and break out a little bit of C# in my case and put that C# into an Azure function. And then within my framework pipelines, I have an Azure function activity that will hit that worker pipeline, tell it to run, pass in whatever parameters I need, and then another Azure function that will sit there monitoring the status of that worker pipeline that is now running. So that is option three, and that's my preferred option. So just to recap, what we now have here is a problem with managing our pipelines. We're overcoming that problem with some metadata. So we're coupling our data factory with our SQL database. But then once we do that, we have this other problem that the execute pipeline activity can't be dynamic. So we have to use something else instead. And in my case, I'm going to use an Azure function app with multiple functions within it to then deal with that as well. So these three services combined is what now gives us a fairly powerful set of resources to then create a framework to actually manage our solutions. So with that in mind, maybe just a side note as well, I have asked Microsoft on several occasions if they're going to make the execute pipeline activity dynamic, and the answer I've got is that it's in the backlog of things to do, but it's a very low priority because there's so many ways to work around it, as you've kind of seen from the three options here. So I'm going to say it's a safe bet to assume that that activity isn't going to become dynamic anytime soon, and we are going to have to use another Azure service or another way of calling those worker pipelines. Anyway, we have three services, and let's now kind of get to the meat of what I want to tell you about, and that is to introduce how I've put these three services together to create this processing framework for Data Factory. And feel free to criticize my icon. Graphic design is not my strength. So I definitely heard a drum roll in the background of introducing this processing framework. And what we have in here that hopefully solves the problem that I've alluded to, and also a bunch of other things as well. I hate bullet points on PowerPoint slides, so I'm certainly not going to read these to you, but hopefully you can see that from these features that I've alluded to, this does address those problems, and this framework is hopefully a fairly good starting point to overcome them and give you a baseline for orchestrating your solutions in a better way. So let's go into the framework itself, and let's take a look at each of those three resources and what I've done with it and how I've glued it together, if you like, to actually make the framework happen. So firstly, the database. In my case, an Azure SQL database is what I've used. And what we have is a good old-fashioned database diagram that I proudly made using Management Studio. And to give you a quick tour of this database to hopefully try and inform what we do next, let's firstly take a look at the core metadata, or the core information that we need to execute. And as I've already alluded to in the earlier slides, we need this idea of a processing stage. and this idea of a pipeline. So this processing stage is the thing that we're going to run sequentially. Those stages will happen sequentially because we have this idea of dependencies between each of those stages. So that's the first thing. Then, as you can gather, that stage is got a one-to-many relationship between our pipelines. So the pipelines table here is basically what houses the information about those worker pipelines that we want the framework to then go and run. And these worker pipelines, in theory, are things that you already have in place in your data factory. Maybe you've already gone so far along with a project, you've got all these workers there, and what you can do is you can take that information from that data factory, pop them straight into this pipelines table. And that's all in theory you would need to do, and you could then say they all exist within the same stage and they would all then run in parallel. But of course, we then have our stages to control the dependencies between them. So those are the first two tables, the core tables that we need, and that core set of metadata that we need to actually drive this thing. Next up, hopefully the name is fairly obvious here, but for any of the worker pipelines that we then want to go and execute, we can, via this metadata framework, also control the parameters that we want. So at runtime, the Azure function that I'll show you in a bit will pass parameters to that worker pipeline driven by some metadata as well. And within the database, we have now a one-to-many between our worker pipelines, our pipelines table, and then the pipeline parameters that we have. And you can gather from the attributes here that we have just a parameter name and a parameter value. So we can have many parameters registered within this table for one worker pipeline. Hopefully fairly obvious. Next up is a table to house information about our data factories. Now, because we're effectively going from data factory to an Azure function that then calls a pipeline, what we can actually do is we can now reach across data factories that exist within the same Azure tenant and the same Azure subscription at the moment. And you can gather from the attributes here, we've got the resource group names in there as well. So if we wanted, we could have our processing framework data factory sat somewhere centrally, and it could just contain the information used for the framework itself. But then we could have our worker pipelines out there in the wilderness in a bunch of other data factories if we want. And this metadata in this table here is what we use to drive that and what supports that behavior. Next up is some authentication details. So I did grapple with this for a while, and what I kind of concluded was that it was simpler to put the service principal details needed to execute those worker pipelines into the metadata database as well. Now, they're obviously not stored in free text. These values will be encrypted and decrypted as they're passed to and from the database. But it means that having these pipelines, we can now have service principals aligned to a single worker pipeline if we wish. And what will happen is that those details are passed to the function, and it will then use those details to authenticate to execute that worker. So those details are stored within our metadata database as well. And hopefully you can gather from the relationships that exist here that those service principal details will be linked to a given worker pipeline for a given data factory, and we control that with our metadata. Next up is a properties table, very much disconnected here from our other metadata, but this properties table now holds a set of global parameters, if you like, that are used to influence the behavior of the processing framework. And I'll talk a little bit more about some of the values that go in there by default and how they influence what the framework is doing. Then Lastly, we have this bunch of 3 tables over on the right-hand side. And these 3 tables, again, no relationships here, but those are the runtime tables, if you like. The current execution table, as the name suggests, will contain details about the execution that is running right now. It exists separately, to make sure there's no sort of performance conflicts here between the current execution of what's happening and then the long-term storage information and the long-term log of what's happened, which we get from the execution log on the top right. And then lastly, again, original naming here, we have an error log. So any pipelines that fail, the activity information that has caused that, the error information of that activity will get put into this error log table. And we have this notion of a local execution ID. So this is something that's created when an execution kicks off, and then we use that local execution ID to track the log information, to track the error information over time. So that's the database. Again, a quick tour of it, but hopefully the tables that you see kind of now alludes to the behavior that I'm about to show you when it comes to the next parts of the framework. So moving on now to the functions that we have within here. What we have in version 1.6 of the framework is currently 4 Azure functions, all sitting within the same function app. The first one is what I've already kind of alluded to, an execute pipeline function, where we will pass in details of the data factory, some authentication information, the name of the pipeline that we want to go and call, obviously fairly important, and then optionally we can pass in some pipeline parameters as well. So that top function will go and hit that worker pipeline, wherever it may be in our subscription, and tell it to run. And once that pipeline is queued and it's in progress, that function will return. Next, again, original naming, is a function that will check the status of that worker. So we can pass in a very similar set of information to that second function, and it will just return the current status of the pipeline, that worker pipeline that's running, just to let us know, is it still in progress? Has it failed? Has it succeeded? Has it been cancelled? What's happened to it? So that function, that second one, will be used quite a lot during an execution to figure out what is happening with that worker. Number 3 is a function that will get the activity error information for us. So we will pass in, along with some stuff, but importantly now, a pipeline run ID. So the unique identifier within our data factory that is attributed to that worker pipeline's execution, and we will use that run ID to then go and fetch any error details if that pipeline returns a status of failed. Then lastly, number 4 is a function that I've actually included in the latest release, but isn't actually implemented yet, which is just a function to send an email. In a later release, I'm planning to include alerting in the framework. I haven't done that yet, but I've kind of just front loaded the development work in the functions app to create that send email function there. All of these 4 functions have been created using C# in my case, and using .NET 3.1, .NET Core 3.1. The kind of the beauty of the functions as well is that within Azure, if you set up your functions app to use a consumption plan, you get something, I think, which is very generous on Microsoft's part, of something like 50,000 minutes of compute for free. So these functions are all very much quick fire, quick return. There's no long running processes here within the functions themselves, which means that using that consumption tier app service plan, you do get a lot of free compute just to help that pipeline, to help that framework run. So that's kind of cost is ultimately a factor here. I'm not paying your Azure bill, but I don't want you to have to be paying too much either. So just bear that in mind, that we don't need an expensive app service plan here. and last time I checked as well, if you're interested, the cheapest app service plan, which gives you like a dedicated resource with like 3.5 gig of RAM, is about £65 a month. So we don't want to have that function app using that compute sat there in an expensive way. So the message here is cheap. I've developed these functions using Visual Studio, but use VS Code if you want. The debug experience that you get locally for both is really cool. I'll show you that shortly as well. Then finally, let's move on to our data factory. Let's have a look at what we have in here and how we're doing for time. Pretty good. So what we have is, and what I've kind of already alluded to already, is this idea of a generational set of pipelines, generational control, if you like. And this is how I like to frame those pipelines, with the grandparent at the top level, which is completely optional, by the way. The grandparent level, within the context of the framework, you can use it for whatever you want. The parent is where we will sequentially execute our stages to handle dependencies. Our child pipeline is where we will then scale out and hit those worker pipelines in parallel where those dependencies don't exist. Our infant pipeline is what we'll use to check on the status of that worker and make sure it's whether it's finished or succeeded or whatever. And then the last one, the worker pipeline, obviously not really fitting in with the generational control here, but those workers, as I've said, are the things that already exist within your data factory or wherever they may be. And a one-to-one, a one-to-many relationship between those low-level activities, I don't mind. However you want to structure those workers, I guess is kind of up to you. So from those pipelines then, if we take a look at the activities themselves, what I've done for the sake of the slides, I've included this image which kind of shows each layer of the activities and how you can go into those for each activities and switch activities and things within Data Factory. Obviously this is horrible to read, so what I'm going to do is, and I've included the link here as well, I'm just going to switch to Visio just so we can kind of explore this activity chain in a bit more detail. So let's get a reasonable level of zoom on the go. So as I've said, the grandparent, completely optional. You do with whatever you see fit with it. I've kind of just included some obvious stuff like maybe we separate our data ingestion, maybe we scale up our environment, whatever, don't mind. The key thing here is though that in my version, the grandparent calls that processing framework, it hits that parent. So next then, if we actually break out into that parent pipeline, what we have is a few things to be aware of. The first one is what I've called this execution wrapper. So this will set up our current execution table, and it will get all of that metadata together in a now sort of nicely structured way that then drives all of this downstream processing. We get other things from our properties table, like the Azure tenant and the subscription, but then quite importantly, we get a distinct list of those processing stages. So those things that are going to execute sequentially. And that distinct list of processing stages is what we then pass off to our first level for each loop. This for each loop is set to run sequentially. And what we do within there is a bunch of other things around handling restarts, which I'll show you in a moment. But the main thing that we have within that first level for each that runs sequentially is the stage executor pipeline. So that stage executor is then what hands off its information about that current stage to this next level of processing. And these, as I say, they happen sequentially. So if we then go down and sort of go into that stage executor, so now we're in sort of that single set of information where all of everything that's downstream is blocked because it has dependencies. but then maybe within that stage we want to scale out. So what we do is within here, we get the information about all of the pipelines that exist within that stage. And that's when we hit our second level for each activity. Now this for each activity will use its default behavior where it will actually execute all of its iterations in parallel. And by default, it will use a batch of 20 executions in parallel. It can be increased to 50, or maybe you might want to control it to 10 or 5 or whatever. But scaling out those executions using this second level for each activity is kind of the important part here. Within that for each activity that's now running in parallel, we get into the actual work of running that worker pipeline itself. And you can see I'm doing things like getting the pipeline parameters from that metadata table. We get the SPN details, so the means of authenticating so we can actually execute that worker. And then we hit our first Azure function, that execute pipeline function that is going to call out to that data factory that contains the worker and says, please start this worker pipeline, queue it, let me know when you're in progress, and then return. Once that function returns and that worker pipeline is actually then in progress, what will happen is it will hand off the remaining run of that worker to the next level, which I've just called the running pipeline handler. Now, the reason for this is that we don't want to use a durable function here. We don't want to have that expensive compute sitting around where that function just blocks and it does its own checking. It isn't going to return an accepted status and then let us know when it's complete. It's going to complete straight away. It says, right, the worker pipeline's running. Now something else take over, let me know when it's done. So we go into our running pipeline handler and we break down into the infant level. Now at the infant level, things get a little bit more fun. So at this point, we're now just checking if that worker pipeline is completed or not. Did it fail? Did it succeed? What happened? So at this level, what we do is what I do is use an until activity. Sit there iterating until that worker has completed. And what we have within that until iteration is our second function that will check the pipeline status. So for every iteration, here's the run ID, has that worker pipeline completed or not, and what was the outcome. If that worker pipeline is still in progress, we get that status back. And if we're in progress, we will wait for the next iteration. Otherwise, we will just return. So assuming we've got then a completed worker pipeline, what we will then do is we'll take the status from that Azure function and we will hand it off to a switch activity. And the switch activity will use a case condition determined by the status of that worker pipeline. We do have a default state in the event that that worker pipeline got cancelled or there was something there that we didn't really know what happened. So we have a default state from that switch activity. We have a succeeded state that will update our metadata that says, yes, your worker was successful. And we have a failed case as well. The failed case, as you can probably imagine, will hit our third Azure function to go and get the error details of those activities that failed within that worker, and it will then log those in the database for us. It will also update our metadata to say that your worker pipeline failed, and it will then block the downstream processes for us. So if we kind of take that information and we kind of bubble this back up in our framework, we have at the lowest level our infant, which is checking for those workers to complete. Those workers would have been executed in parallel by our child within that stage. And then bubbled up further, when that stage completes, our parent will move on to the next stage and we'll start all over again with everything below. Finally, our parent might return and bubble back up to our optional grandparent, and then we might finish off our platform doing something else that we haven't included in our metadata framework for whatever reason. So that's the activity chain. There's obviously a few nuances. There's a lot of things being passed around here, but this is all now boilerplate code that we can reuse every time for that fairly simple set of original metadata that was the stages and the pipelines, that original thing that we wanted to deal with because we had those dependencies in there. So closing that, and now if we actually have a look at the thing running, if we actually see this now in operation as kind of just the final part of this talk, I've said the grandparent is entirely optional, so my grandparent does basically nothing within this demo environment, but my parent is what I've already shown you via Visio, and what I'm going to do is I'm just going to not run it. What I'm going to do is I want to show you how the framework will also restart. So within my pipeline parameters table, I've got an intentional error pipeline, which I'll show you shortly. I'm just going to set that to true. And then I've got a bunch of other parameters for my workers that I have registered. And you'll probably gather from these workers, they're not very imaginative. So what I've got within my data factory, along with my processing framework pipelines, I have a bunch of workers in here as well, just so the framework is going to go and execute something. These workers are the most complicated pipelines in the world, and all we have is a pipeline parameter of a wait in seconds, which gets passed off to a wait activity that also receives that information. So a bunch of wait type worker pipelines and a worker pipeline that is intentionally going to error by raising an exception in a Databricks notebook with some Scala and raising an error in some T-SQL with a store procedure. So those are my workers, and I want this one to intentionally fail, as the name suggests. So let's trigger my parent pipeline and let's see what happens. Let's have a look at the metadata behind it. And I'll go into my data factory monitoring. You can see when I was testing this earlier today, just to make sure we're all good, I've got some previous executions. That worker is going to kick off. And then if I look at my metadata database and the current execution table, what's already happened is that that execution wrapper has got the information and we've kicked off stage 1 of processing, and all of those worker pipelines are now in a running state. So let's just refresh again. What's happened next is that they've started running, they're in progress, and they've passed off their information then to the infant if they've passed off their run ID. And now the infant has very much taken over and said, okay, these are running. I'm now going to hit that until activity and start iterating until they complete. So pipeline wait 2 has completed. We have a success status. What you probably gathered from my pipeline parameters is that these wait values are all very demo friendly. There's nothing heavy happening in those workers. We want this obviously to complete fairly quickly. So successors, one of the properties that we have within the properties table is a wait in seconds for every iteration of that until. So if you want it to iterate quicker at that infant level, you can speed it up. Or, maybe if you're expecting a Databricks cluster to start up and you've got to wait for it, then that will happen a bit slower as well. But in theory, what we're now waiting for is that infant just to iterate and return the status of that worker, which it has, success. I just hit refresh a little more rapidly now. So what the framework's doing is we've bubbled up from that first stage of execution, and we'll now get into our second stage, which gets a preparing state firstly. So a few more refreshes. I was always told it'll go faster if you keep hitting F5. Of course not. So we're now running our second stage of execution. We've got that intentional error worker pipeline there. What you'll also see on the right-hand side of this current execution table is that we capture those parameters that are being passed at runtime as well. So, we have all of that log information. Wait 1 has actually happened successfully. That's nice. Maybe I should have made this go a little faster, given we're running a little short on time. Are we still okay for time, Michael?
We've got a couple of minutes left.
You're enjoying it too much, right? You need to watch it finish.
That's it, all the way.
What I just wanted to show you really was the restartability of the framework. So this intentional error one, you can imagine that it's hitting the Databricks notebook. So the intentional error pipeline has failed. Good. We're just waiting for that infant iteration, which you can see is 55 seconds. So it probably went through 2 iterations there, because my property is set to 30 seconds. So yeah, then that infant will raise an error because the worker has errored, and that will sort of bubble up that failure eventually to the parent, he says. Again, it's one of those things where the more you click, the faster it will go. Come on, parent. Check for blockers. Thank you. So because of that intentional error, we've bubbled up that failure. Let's check the execution. We see that we get a failed state, and we'll also then see that that was in stage 2 where the failure occurred. So then what's happened is all of my downstream stages now get this blocked status, because that's what we want to happen. We can, if we want, via Data Factory, maybe we have our Data Factories disconnected, maybe the workers aren't in the same Data Factory as the framework is. So what we could do is we could say, oh, yes, okay, I know it was that stage that failed, so I can go into the child. I can then say that, okay, what happened? Well, here's the infant that was called. So let's go into that infant and let's have a look. We can see the result of the switch activity was a failure, because we had that condition where this failed. So we can then say, okay, our failed pipeline status, and what we actually then get returned here, if we wanted, is the run ID of that pipeline that actually caused the failure, or the worker that caused the failure. So from the framework itself, we get a little insight into that. And what we could, in theory, do is then go back to the monitoring of our Data Factory where the worker exists. We could paste in that run ID, and we can see, yes, it was our intentional error that caused it. What we also get via the metadata framework is that error log information. So as you can probably expect, if I go into this intentional error, we look at our notebook failure, we do get a link to the Databricks job, so we can actually go to that notebook and look at it. And we do also get the raised error information from the T-SQL as well, but this was an intentional failure. So we get that same information if we look at the error log via the metadata. If I just hit paste again for that run ID, you see we have that pipeline run ID here, and that same error information that we saw via the Data Factory monitoring portal, we get that in the metadata database as well now within this table. So let's assume that we fixed our worker pipeline. there was some problem that was, out of scope of the framework, and we go and get information that that worker has now been fixed. In my case, I'm just going to change the parameter so it doesn't raise an error. And let's just check. So now what we could do is ultimately, we don't want the framework to start from the beginning because we've already got some successes here. So what we could do is we go into our monitoring, we say, yes, we know there's failures, but really all I want to do is for that parent, I'm just going to hit rerun and please pick up from where you left off. There is a property to control this. If you don't want that behavior and you do just want it to start again, it will do that as well. But in my case, the default is restart. So it will leave the successes intact, but then for that pipeline or pipelines that failed, it will then get rid of the values and it will then start the running of the framework again. So it very much will pick up from where it's left off. The downstream stages become unblocked, and we can very much just get on with our lives. Of course, my worker pipeline fix was very easy. If we go back to our monitoring and hit refresh, we see the existing error remains intact, but because we hit rerun, it's got rid of those failed pipelines from the child and things, just so we don't have a messy Azure monitor here. We see that failure, but then we only care about what was actually the problem. So my intentional error has now succeeded because it was a parameter that controlled it, and we're now just waiting for that infant to finish its iterations to confirm it's complete. I'm sure you can guess what's going to happen next. Please go faster, I'm overrun. I know you're all excited to see this finish. Let's just do a refresh in the database. So yes, we have succeeded, the infant's returned, and we will break out into the other stages. I won't bore you with them finishing. What I'll do is I'll quickly wrap up and just say that in addition to the framework, I've created a Power BI dashboard if that's what you prefer to use to monitor your executions. Nothing too exciting here, but one visual that was quite interesting and was quite fun to create was what I've called this worker parallelism over time. So if I pick a given execution that took this long to run and then duration, if we look at that worker parallelism, we can see that at this point we had 4 workers running in parallel. They finished. You can see by the tooltips that we had 2 pipelines running. We then, for that first stage, had 1 worker, and then we hit our second stage and we get a parallelism of 4 again for that particular execution stage. So this was just a visual that I enjoyed creating to actually then represent within that stage of execution those different workers that are going to run. Very much inspired by an ex-colleague of mine, Richard Swinbank, who may or may not be listening. Our execution is still running, but so I won't bore you with that. Hopefully you've seen enough to be excited. What I'll do is I'll just drop back to my final slides. So there is our activity chain. Here is my summary of how those pipeline hierarchies now fit into the framework with the grandparents through to the workers. So please take those definitions away and bear in mind that those workers could exist in a separate data factory if you like. So that is it from me, folks. Thank you very much for listening. As I've said, the slides are available in GitHub. The link there to the processing framework also in its own GitHub repository. And as a special thank you for you guys, I've released version 1.6 of the processing framework today to kind of mark the occasion for this virtual chapter. Thank you.
All right, thank you, Paul. Yeah. Great stuff. Okay, so we'll just take a couple of questions and then we'll let everybody get on with their day. Lots
Indeed.
of exciting things happening at Boulder. Okay, so as you might expect, a couple of questions just comparing this to BIML.
BIML.
So Bimble, yeah, you know that thing, right? You've heard of it.
Sure.
Yeah, so I mean, that's exactly where my frame of reference is as well. I come from an SSIS background, not so much data factory. So the first one is, have you used Bimble in the SSIS world? Okay, so, well, just straight up.
Yes, I have used it in the SIS world, but for me, I mean, correct me if I'm wrong here, but where I've used Bimble was very much a deployment time to create my sys packages and set them up for execution. So Bimble was for me a deployment time tool, whereas this is more of a runtime tool, if it's okay to make that distinction.
Yep. So totally fair. And then Gasper would say similar sort of question. Are you able to generate pipeline JSON as it is with Bimble framework and then deploy it?
I believe so. You might want to have a chat with Scott Curry about that one, but I'm fairly sure we can use Bimble to generate data factory pipelines now if you want to use that metadata and do that kind of deployment time thing again. I think that's possible. I heard that it was going to be possible, but I don't know exactly. But yeah,
Cool.
maybe tweet Scott about that one.
Okay. Just as I mentioned, this question will come up again. Yes, the session is recorded. The video will be made within the next 24 hours. So I'll post those out. We have a question from Conrad. It says, are there jobs for only ADF developers?
Are there jobs for only ADF developers?
Are you speaking about employment type jobs or execution jobs, I guess?
I would assume employment jobs at that point, and I guess I would say that's, for me, Data Factory is part of a data engineering role, I would say. Maybe. I don't know. I've not looked for a job for a while. Sorry, I don't have a good answer. But for me, I don't think there's Data Factory only jobs. I think Data Factory is one tool that a data engineer may use amongst others. It would be my view on it.
All right. Yeah, thanks. And I think that's the story with Azure, right? Everybody needs to know multiple tools nowadays to get a job done. Ginger
yes, the
would like to know.
Depth of knowledge.
Okay, Ginger would like, for someone who wants an ADF job, there is one in. Oh, there we go. Ginger has a job. Will be on the AZ
Hi, Ginger.
Yes, the video will be recorded and made available in the next 24 hours. Steve would like to know, extending dynamic concepts. What challenges have you had with dynamic content for the dataset source property using dynamic SQL and variables? Noticed metadata challenges is on the data set cache.
Yeah, good question. So I'm going to dodge the question slightly by I guess saying that this framework doesn't do anything at the data set level when it comes to handling your content dynamically. It very much deals with the pipeline level execution. So anything with your data sets that might be used with your activities at that lower level, there's nothing here that injects into that. But I guess as for challenges, it's hard to say. I guess it would very much depend on the data set you're working with, what that source system is, or what that tool is you're interacting with. So yeah, maybe if I could dodge the question in that way.
Cool. Gasper would like to know, is this framework available for free?
Yeah. If you want to pay me, then fine. But yeah,
you can buy Paul a beer. I'm sure he would love that. So,
yeah, beer.
Set yourself up one of them Patreon accounts, right?
Yeah.
Okay, it's the last question. I just have one question before we. So I'm not quite sure how Data Factory billing works, but I know similar to what you've done here. When we did the same thing with SSIS, we generated a lot of jobs.
Yeah.
Are you charged per? How is the execution? Are you, is there a benefit in trying to cram everything into a single activity, or or does that not really matter from a pricing perspective?
Yeah, so the Data Factory charging model, I think, is one of the most complicated that I've looked at in the Azure price calculator, just because there's so many different moving parts to it. You have your your copy data movement units, which are charged separately. You then have, if you're using the data flow capability, you have the cluster costs underneath that. But then to maybe answer your question directly, yes, the Data Factory calculator, it charges you per activity executions. And I think last time I checked, it was some amount of money for the first 50,000 activity executions, and then some other pence more for the activity executions beyond that. So yes, I think is the answer to your question, that it is an advantage to cram stuff into a single activity because that's how it's charged. But Data Factory for me is probably the least of your worries when it comes to costs in Azure. It's not the orchestration tool costs you've got to worry about. It's everything else that Data Factories then go and poke and prod and touch. So maybe a Databricks cluster, maybe an Azure SQL database, maybe analysis services. Data Factory is orchestrating those other components as well. So it's the cost of those tools doing the work that I would worry about more so than Data Factory. My SQL DB that I used for demo was set at an S2 with 10 DTUs, so very cheap, and that handled that for the chatter that I had between Data Factory and the database. So yeah, a few things to consider, and yes is the direct answer to your question, but
not so big. Right, thanks a lot. I think that's us for the day. I'd just like to remind all our attendees that there will be a survey that'll appear after the session ends. If you could fill that in, that provides valuable feedback for both ourselves and our speakers. So we'd appreciate if you could fill that in. Then we'd like to thank you, Paul, again, one last time. And we look forward to seeing everybody next week when we'll be speaking about, I think it's the Power BI SSRS on-prem reporting services, the deep dive. All right, thanks everyone, and see you next week.
Thank you everyone, bye.
Cheers.